So notice now when we're trying to solve algebraic equations, sometimes, if possible, we'll want to clean up each side first. And this is just a way of saying combine like terms. For instance, we have a 2x and a 9x on the same side of the equal sign. We're not going to get rid of one or the other. We're going to combine them. So 2x positive 9x combine to give us 11x. So we've taken care of that, we've taken care of that. And this negative 8 will just come down, bring down the equal sign, and everything on the other side. Notice we had no like terms over here, we couldn't combine them. Now we're going to start to get rid of whatever we don't want. I'll get rid of the 6x first, that way I won't have negative variables. Also put a negative 6x on the other side of the equal. Just draw a line and bring everything down. This gives us 5x. Bring down the negative 8. Bring down your equal sign. That's a 0. I don't have to write it. And we still have negative 38. Next we'll get rid of the negative 8. It's held by addition or subtraction, so I'll put a positive 8. Go to the other side of the equal, put a positive 8. Draw a line, bring everything down. We have 5x, that's a 0, I don't have to write it. Now we have, signs are different, subtract, keep the sign of the larger, negative 30. One more step, we want to get rid of the 5, it's held by multiplication, so I will divide by 5. I will divide by 5. 5 goes into 5 one time, so I have 1x, but usually we just write x. Negative 30 divided by 5 is negative 6. So this is our solution. Turning our attention over here. Again, we're going to want to clean up on one side of the equal sign if we can. We have like terms here, a 3y and a 5y, but this is inside parentheses. I can't just combine it with the 3y. I have to distribute the negative 2 to get rid of the parentheses, and then I'll be able to combine like terms. Negative 2 times 5y, negative 10y. Negative 2 times negative 7 is positive 14. Now I'll just bring down everything I haven't touched. I already used that negative, so all I have to do is bring down the 3y. And of course the equal sign, negative 9y, and this 6. Now we have two like terms on the same side of the equal, so I'm going to combine them. Positive 3, negative 10 gives us negative 7y. Bring down the 14. Now there's no more like terms on one side of the equal sign. So I could get rid of any one of these four terms. If I get rid of the negative 9y, I won't have a negative in front of a variable. So that's what I'm going to do first. To get rid of a negative 9y, this term is held by addition or subtraction. I'll combine it with a positive 9y. Put a positive 9y on the other side of the equal sign. We'll just draw a line and bring everything down. This yields a positive 2y. Bring down our 14. The equal sign. That's a 0. I don't have to bother to write it. Oops. I really don't need that positive sign, but I'll leave it there. I could have just brought down the 6. I'm still trying to get y by itself. I'll get rid of this 14. I'll mention I could divide each term by 2, but usually it's easier to add or subtract first, so that's what I'm going to do. Again, it's sort of order of operations in reverse when you're trying to solve an algebraic equation. So I'll get rid of this positive 14 with a negative 14. Bring down the 2y, the equal sign. Signs are different. We'll subtract, keep the sign of the larger. It's going to be a negative 8. And one more step. We want to get rid of that 2. It's held by multiplication, so I'll divide by 2, divide by 2. 2 goes into 2 once, so we have 1y, or I'll just write y. Negative 8 divided by 2 is negative 4. And I will mention you could take this negative 4, plug it in wherever there's a y, and you will get a true statement. In trying to solve this equation, we'll be able to combine like terms here, and we'll have to get rid of these parentheses. So it's possible to clean up each side, and that's what we'll do. Send in that negative 3 to each term. This gives us a negative 12k. Negative 3 times 9 is negative 27. And on the other side, these are like terms, so we can combine them. Negative 6, negative 7, signs are the same, so we add and keep the sign. Negative 13, k just comes along for the ride. And we'll bring down the equal sign. So we've taken care of cleaning up each side. Now we'll just decide what we want to get rid of and use the opposite operation to get rid of it. I have a negative 13k here, a negative 12k here. This side of the equal sign has more clutter on it. So I'm going to get rid of this negative 12k, even though I'm still going to be stuck with a negative variable. But generally, I worry about the side of the equal sign that's the most cluttered. So that's negative 12k. To get rid of it, I'll put plus 12k. Go to the other side of the equal sign, plus 12k. This leaves us with a negative k, or negative 1k, equals, that's a 0. I don't have to write it because I have a negative 27 over here. I still don't have k all by itself. And remember, the goal is to get x by itself. In this instance, we have a k. I have a negative in front, so I need to get rid of that negative sign. This is a negative 1 times k, so I can get rid of it with the opposite operation. I'll divide by negative 1, come to the other side of the equal sign, divide by negative 1. Negative 1 divided by negative 1 is a positive 1. So I have 1k, or just k. Negative 27 divided by negative 1 is positive 27. So this is our solution. I'll mention I divide each side by -1 just to be consistent with using the opposite operation, because this always works. But if you think about it, you could multiply each side by a -1, and you would still end up with a positive k, which is your goal. Back here, when I said, okay, I'm going to get rid of this -12k, I want to show what would happen if you decided to get rid of the -13k. You can, it just ends up looking strange. So I'm going to rewrite it at this point. We had -13k equals -12k minus 27. I could say -27. The words are more or less interchangeable. If you said, well, I'm going to get rid of this -13k, it's not, this whole term is not being held by multiplication or division, so you can get rid of it with a positive 13k. So if I put a positive 13k here, I have to put a positive 13k over here. Now I draw a line and bring everything down. Normally, when terms zero out, I don't have to write the 0, but I can't leave air on this side of the equal sign. So in this case, I have to put the 0. This gives us 1k, or I could just write the k, bring down the -27, and now you have 0 is equal to k minus 27. You have to get rid of that -27. So you'd say plus 27 or positive 27. And you come to the other side of the equal and you put a positive 27. Then you draw a line. Over here, 0, positive 27, well, that leaves you with 27. And over here, that zeroes out, I don't have to write it, and I have k. So notice I get the same answer. So we can combine like terms here. Positive 10, negative 13 yields a -3. And the x just comes along. So we've taken care of that, we've taken care of that. We just have our positive 9. And bring down everything on the other side. Oh, we have two like terms. So we can combine positive 8, negative 20, combine to give us a -12. It'd be kind of a waste of time to get rid of the -3x because I just have a term over here with no variable. So I'll get rid of the 9. So I'll put a -9 underneath. Come over here, put down a -9. This gives us -21. Bring down the equal sign. And that's a 0. I don't have to write it. Just bring down the -3x. Now I want to get rid of that -3. So I will divide by -3 and divide by -3. -3 goes into -3 one time. So you have 1x or x. And -21 divided by -3 is a positive 7. So that's our solution. We'll look at one more equation here. I have like terms on the same side of the equal, but this is trapped inside parentheses, so I have to get rid of the parentheses. The negative sign in front, usually we'll just say distribute the negative. If it helps you to think of that as a -1, that's acceptable. So I'll distribute that to each term. This would be a -2r, and this would become a +7. And then I'll bring down whatever I haven't touched. This +3r is coming down, as well as the equal sign and the 12. On this side of the equal, we have like terms, -2r, +3r, combined to give us 1r, or I can just write the r. And then we have a 5 and a 7, both of them are positive, so we combine them and we get a +12. Notice all this was on the same side of the equal sign. I wasn't getting rid of anything. I was just combining like terms. Okay, now to get r by itself, we just need to get rid of that 12. I'll put a -12 on each side of the equal sign. Bring down the r. This is a 0, I don't need to write it, but on the other side of the equal, I can't leave air. +12, -12 is 0. So 0 is the solution to this equation. If you plug in a 0 wherever there's a r, you will get a true statement. And as always, if you go to my website, you'll have a practice worksheet with a detailed answer key.